Hello, this is a quick review of Learning Target 2.1. I can use inverse operations to solve and check multi-step equations. When I take a look at number 1, right away I see a set of parentheses. What you want to do first is to get rid of the parentheses by doing the distributive property. So I'm going to take my 2 and I'm going to multiply it by each term in the quantity. So I go 2 times x is 2x, 2 times 3 is a positive 6, equals 10. Okay, so we simplified there. Now we want to solve using inverse operations. So I want to get rid of my constant first, my 6, so I do the opposite of adding 6. I subtract 6 from both sides of the equal sign. And we end up getting 2x is equal to 4. Well, now I have a one-step equation. It's 2 times x, so the opposite of multiplying, I'm going to divide by 2. We end up getting x equals 2 as our solution. Now it says also to check your solution. So what you do is wherever you see an x, you plug that 2 back in. So I've got 2 times 2 plus 3 is equal to 10, and I'm proving that that's true. Well, with these check problems, you always want to do PEMDAS or GEMDAS here for evaluating. So I want to do parentheses first. I get 2 times 5 equals 10. Is that true? Well, 2 times 5 is 10, so it is true. So it works. So you can put a check mark there. All right, moving on to number 2. If you take a look, we've got some like terms that we need to simplify first. So what I would do is square them, and remember to bring the sign that's in front of it with it. So I'm going to rewrite this. I get 6x minus 8x plus 3 equals 13. Whenever we combine terms, they have to have the same variable with the same exponent. So these are both x's, so we're good. Then you just combine the coefficients. So 6 minus 8 is a negative 2x plus 3 equals 13. Now we have a two-step equation, so now we can get rid of our constant by subtracting 3 from both sides of the equal sign. We get a negative 2x is equal to a positive 10. Now it's a one-step equation. I can divide by a negative 2. We end up getting x is equal to a negative 5. Alright, so to prove it, we have to plug it back in. So we go 6 times a negative 5 plus 3 minus 8 times a negative 5. Is that equal to 13? Well, again, let's do PEMDAS first. So we focus on our multiplication problems here. 6 times negative 5 is a negative 30, plus 3. Negative 8 times negative 5 is a positive 40. And then we can prove, does it equal 13? So negative 30 plus 3 is a negative 27 plus 40. Negative 27 plus 40 is a positive 13. So it does work. Alright, moving on to number 3. I take a look at this equation. Looks like I have some simplifying to do before I can start solving. So what I would do is get rid of the parentheses first by doing the distributive property. So we get a negative 2 times 3n is a negative 6n. Negative 2 times a positive n is a negative 2n. Rewrite my plus 12 and then we want to set that equal to negative 4. Well, before I solve, I need to combine like terms. So I have a negative 6n minus 2n. We get a negative 8n plus 12 is equal to a negative 4. Now we have our two-step equation, so I get rid of my constant first by doing the inverse operation. We get a negative 8n is equal to a negative 16. Divide both sides by a negative 8. We get n is equal to a positive 2. To check my work, I plug that back in to my original equation over here. So we get negative 2 times the quantity 3 times 2 plus plus 12, is that equal to a negative 4? Again, we're going to do PEMDAS to solve. So I start with my parentheses and then I go work within. I'm going to work with my multiplication first. So I rewrite negative 2 times 6 plus 2 plus 12, is that equal to a negative 4? Well, now we're still focusing on parentheses, so I go negative 2 times 8 plus 12, is that equal to a negative 4? Negative 2 times 8 is a negative 16 plus 12, and we do get negative 4 is equal to a negative 4. So it does work out. Okay, one more problem. Same type of steps here. We have to do the distributive property and then maybe some combining like terms. So wherever I see parentheses, I'm going to take that term and distribute it. 5 times 1 is 5. 5 times a negative 2w. Or if you want to change this, we can zoom in a little bit. Change this to be plus a negative 2w, if that helps you understand it a little better. But then we are multiplying it by a negative 2w, so we get minus 10w plus 8w. Now we can combine like terms, so we have a negative 10w plus 8w. So it's negative 10 plus 8. We're going to rewrite my 5 minus 2w is equal to 15. Okay, so first step, I want to get rid of my constant, which is my 5 here. Notice the sign that's in front of it. It's a positive 5, so I'm going to do the opposite. I'm going to do the inverse operation. I'm going to subtract 5 from both sides, the equal sign. We end up getting 10 is equal to a negative 2w. And then we can, it's a one-step equation. Let's divide by negative 2. We get negative 5 is equal to w. Okay, now let's prove it to make sure we're right. So is 15 equal to 5 times 1 minus 2 times a negative 5 plus 8 times a negative 5? This is kind of like that other check up there. So we're going to do the same thing. We're going to work with our parentheses first and then do the multiplication within. So we get 5 times 1 minus a negative 10 plus 8 times a negative 5. Here, this when you subtract a negative, that becomes an addition sign. So we get 5 times 11 plus 8 times a negative 5. Well, 5 times 11 is 55 plus 8 times negative 5 is a negative 40. So we're proving, does that equal to 15? Well, 55 plus a negative 40 is equal to 15, so we're good. 15 is equal to 15. All right, that was just a quick review. If you need more help, please come in early before school or after school to get help. Thanks. Bye.